This is 7.2, graphing rational functions. So what are the characteristics of rational functions? That's what you're going to learn today. Alright, so this is the first video, and we're going to just be graphing a translation of a rational function. Okay? So, let's go for vocabulary. What's a rational function? So, it has the form f of x equals p of x over q of x, where p of x and q of x are polynomials. So it's one polynomial divided by another, and q of x cannot equal 0 because we cannot divide by 0. Okay? Core concept for that looks like this. So in this case, our polynomial is 1, and our p of x is 1, and then q of x is x. So this graph has an asymptote on the y-axis and on the x-axis. So it never actually crosses either of those. And it does have a graph in opposite quadrants, okay? This is called a hyperbola. Okay, it's two symmetrical parts called branches. The domain and range are all non-zero real numbers, okay? Because obviously it can't equal y being 0, the range can't, and the domain can't be x equals 0. Okay? Has the same asymptotes and range no matter what the number is on top. Okay, but notice there's no translating these. There's no moving things right or left or up or down. Okay, and so that does mean the asymptotes stay put on those axes because there's no plus or minus in this problem. Okay, so let's give this a try. We're going to graph this function. So it looks just like that function, only it has a 4 on the top, and it's divided by x. Okay, so I know I have asymptotes, and I'm going to put them on here. You know, usually, like if you were to graph this, the asymptotes don't show up. I like to put them on so I know not to cross those axes, okay, those axes. So the y-axis is one of them, and the x-axis is one of them. So I'm not going to cross those orange dotted lines. All right, but like I said, your graph doesn't have to have that part. And then we know from the definition here, okay, no matter what that a is, if it's a number over x, the domain and range has the same as 1 over x, okay, and that is all non-zero real numbers. So my domain and range here, I'm only going to write it once, are all non-zero real numbers. Okay? And if I were to write this in interval notation, we know they go from negative infinity to 0, but doesn't equal 0, so it gets parentheses. And then we put that little union symbol there, and it goes from 0 to infinity, not equaling 0. That means 0 is in between these, and it doesn't equal those, okay? So, but this is how big ideas will have it. All right, but let's work on getting the rest of our graph there. We did do this part. We stated our domain and range, okay? But we need to actually graph this function. So I'm going to do that by getting some values of x and y. Okay? I can plug numbers in here and get the y, so 4 divided by whatever I put in for x, but it's just as easy if I have, since we have the calculator to do this, okay, I'm going to go y equals, and it's 4 divided by x. And I'm just going to get a table. It's going to give me 1. Okay? And I don't need to go too terribly far here. So I have a negative 4 is negative 1. I'm going to just put the exact one. So there I have a negative 2 is at negative 2. Negative 1 is at negative 4. And notice that 0 has an error. That's because there's an asymptote there. Okay? And then I have 1, 4. So I'm just drawing that. That's my asymptote. Okay? Then I have 1, 4, 2, 2, and 4, 1. Okay? I'm just writing those whole numbers in there. Okay? So if I plot those, negative 4, negative 1, negative 2, negative 2, negative 1, negative 4. So you can kind of see the curve here. So I'm going to, it's going to come from this curve, or this asymptote, and go towards the other one in that quadrant. Okay? And then I still have these points because there was the asymptote moving over on the x value. So 1, I'm at 4. 2, I'm at 2, and then 4, I'm at 1. And draw your curve in there. Okay? So, again, if I were to take 4 and I divide by negative 4, I get negative 1. If I take 4 and I divide by negative 2, I get negative 2. 4 divided by negative 1 is negative 4. So if I would have done negative 3, I would have gotten a decimal, which is fine. You can still graph that. It's just I find it easier to graph the whole numbers. All right. So I do want you to go to part of your practice. Actually, I don't want you to go to your practice. I want you to hold off on that and watch the next video where we're actually going to start doing translations to these functions.